Hi everyone, so today we're going to be working on evaluating inverse trig functions. As many of you guys might remember, inverse is when you switch the domain and the range. So it becomes y comma x instead of x comma y as a coordinate point. And when you graph this function, you're still able to pass the vertical line test. And it's important for you to remember that cosine represents the x values on a unit circle and sine represents the y value on a unit circle. So on your test or quizzes, you might see inverse trig as written as sine to the -1 or arc sine or cosine or arc tangent. The unit circle is very important for this unit because it's going to be your calculator because all the angles and all the coordinate points are located on there. So we're going to start with sine, and what you need to think about is what angle corresponds with the y value that you're given. The range of this angle has to stay between -pi/2 and pi/2. And next, we're going to be looking at cosine. So what you need to be asking yourself is what angle corresponds with this given x value you're given. And your angles have to be within the range of 0 and pi. Last but not least, we're going to be looking at tangent. Tangent is your sine divided by your cosine. And your range is between -pi/2 and pi/2. So let's try some examples that include you evaluating inverse trig functions. So we're going to start with sine, inverse sine, -2/2. Also remember that inverse trig can be written as arc sine or arc cosine or arc tangent. They are used interchangeably, so they all mean the same exact thing. But for inverse sine, -2/2, we need to find the the angle that has a y value of -2/2. In this case, it's a 7 pi/4. However, 7 pi/4 is out of the range of -pi/2 to pi/2. But if you look on this graph that shows the range of sine, you'll be able to see that 7 pi/4 corresponds with the angle -pi/4. So your answer would be -pi/4 instead of 7 pi/4 because it fits the range of sine. Next, we have our examples for cosine. And for cosine, our example is inverse cosine of -√3/2. So we need to find the x value, the angle that has the x value of -√3/2, which in this case is 5 pi/6. 5 pi/6 is within the range of 0 and pi, so it is in this the range of cosine. So our answer will be 5 pi/6. Always make sure that your answer is within the range of the specific trig function. For tangent, we know that tangent is sine over cosine, or in other words, y divided by x. So I'm going to go ahead and show you how to find your tangent for pi/3. So your y is square root of 3/2, and then 1 divided by 1/2. As you can see, they have like denominators of 2, so you can go ahead and cancel that out, and you'll be left with square root of 3. And then go ahead and find your tangent for pi/4 and pi/6. For pi/4, your tangent will be 1, and then for pi/6, your tangent will be square root of 3/3. So the example says, what is the inverse tangent of square root of 3/3? So the inverse tangent of square root of 3/3, so which angle has a tangent that equals the square root of 3/3? Well, in this case, this angle was pi/6, so your answer will be pi/6. Ooh, I'm sorry, 6. Okay, so for our next example is going to be combining all of the inverse trig functions plus some just basic trig functions on the unit circle. So our first example, we're going to have to work from the inside out. So what is the x value that corresponds with the angle 7 pi/6? So the x value that corresponds with that angle is negative square root of 3 over 2. So it will be negative square root of 3 over 2. So what is the inverse sine of this? So which angle has a y value that is at negative square root of 3 over 2? Well, as we can see right here, the angle that has that is 5 pi over 3. Well, we can't have a, this is out of the range of sine, which is from negative pi over 2 to pi over 2. But we look up here, this also has square root of 3 over 2. But if we were to add a negative in front of pi over 3, it will make it equal to negative square root of 3 over 2. So our answer will be negative pi over 3. So our next one is asking us what is the y value for pi over 2. Well, the y value for pi over 2 is right here, and the y value is 1. So that would be 1. So then it's now inverse tangent of 1. So which, as we saw before in this graph, we were looking for the angle that has a tangent of 1, and that is pi over 4. So our answer will be pi over 4. Our next one, we need to find what the the inverse sine of square root of 3 over 2 is. So square root of 3 over 2, which angle corresponds to square root of 3 over 2 as a y value? So right here we have square root of 3 over 2. So our answer will just be pi over 3. So inverse sine of square root of 3 over 2 is just pi over 3. And then we have to find the cosine of pi over 3, which this is just the x value of pi over 3. The x value of pi over 3 is 1/2, so our answer will be 1/2. So I hope you are able to learn how to evaluate inverse trig functions through this video. Here I've added some extra links, a video that goes more in depth into inverse trig functions, and a Khan Academy video and practice for you to work on. Thank you.